This conference will now be recorded.
Hello everyone, this is Ryan, and we're going to take a quick look at helioscopes. Helioscopes are a blueprint of what a solar system could look like on a house, as well as what the production and output could be of any one particular system. Let's jump on into it. So when you receive a helioscope, you will actually receive two separate PDF documents, okay? One is essentially going to be an annual production report, okay? And the other one is essentially going to be the shading report, all right? So to start with the annual production report, we'll see here that it has the address, okay? We'll see what the system size is and its details, 14.8 kilowatt, annual output, 19.17 megawatt hours, or 19,170 kilowatt hours. And if we go down a little bit further, we'll see some more specs and details. Now, we're not going to go over every single credential on here because a lot of it's for the engineers, but from a sales perspective, I'm going to highlight what's essential. So system size, system output. This is the standard bell curve on a 12-month calendar year. If we look down here, we can see essentially what is the bottom line energy to grid? Where exactly is it going? What is the irritance going to be? What are the coefficients and deltas that might impact that? Okay. If we go down a little bit further, we can see what are the panels that we're using. The Hyundai 370 Industrials. Okay. A little bit further down, we can see where we'd like to put them on the roof. All right. Now, over here are the inverters. Okay. I'm going to be using the Solar Edge power optimizers. And in general, we just have one array here, array A, which has 40 panels on it, totaling a 14.8 kilowatt system. All of the green blobs or dots, those are trees. The larger the dot, the larger the tree, and the higher the impact may be. But to see the true impact of the shading, we're going to go to the shading report. As you see, it's the same image, but now it has a heat map. If we look at our key, we see that the redder it is, the more shading it is receiving, and the brighter the green, the less shading it's receiving, so the higher the production. So we can see this system here, and based on the copious amount of green blobs, it's definitely getting a little bit of shading. Now, does that mean solar isn't possible? Not necessarily. It just means you may have to add a few more panels to offset that or work with them to reduce their energy consumption. Okay. When you look at percentages, we'll see that red is giving about 70% and green is giving 100%. So if a panel was producing 370 watts, this is suggesting you might only be getting 70% of that output throughout some of the shady points and times. Okay. To look at that a little further, it continues to break down the system. It had one array, A, 40 modules, total system size, and total megawatt output. Okay. Overall, when you take all of these panels into account, all the reds, oranges, and yellows, it's saying it's going to have about a 78.6 or 79% overall coverage. So if you were trying to get to 20,000 kilowatt hours, you're pretty close, right? But if you were trying to get to 24,000 kilowatt hours or 24 megawatt hours, you would clearly need to add some more panels here. Okay, maybe you'd need to consider another array over here. Maybe the shading just gets even worse over here. We could deduce to that because we see it's getting redder and redder the closer we get to this tree line. Okay, now the helioscope is reasonably accurate, but it's not a perfect science. This is for you to use to 1, be more professional, 2, be better prepared, and 3, ethically size a solar system here. Okay, you can request your own helioscope for your referrals or self-generated appointments by sending a request to, solarprelims@visionce.com. We have a partnership with them. Send them the address, the system specs, and they will send you your simulation and shading report. Email me at ryan@nrgcleanpower.com if you have any questions. Have a great day.